Welcome. This is Adam Racklin from MathTutorMan.com, and in this video what we're going to be doing is going to be discussing integration by parts. This is one of the well-known techniques for performing integrations. The form of integration by parts is the integral of u dv equals uv minus the integral of v du. What this means is that you're going to be usually using integration by parts. You usually use it when you have an integration of a function which is both a polynomial times a transcendental function. For example, in the problem that we're going to do today, you want to know what the indefinite integral of x to the fourth, that's your polynomial, times the natural log of x. And the natural log is a transcendental function. So let's get started. What you're going to do is the first thing you're going to do is you're going to rewrite, okay, this problem, okay, in this form. The indefinite integral of the natural log of x times x to the fourth dx, okay? And what's going to happen is you need to determine which one of these functions, is it the transcendental function or is it the polynomial function? Is that going to be u or v? Well, for this problem, what's going to happen is that this is going to be u, and we're going to let this equal dv. Therefore, what's happening is we're saying let u equal the natural log of x and derivative of v equal x to the fourth dx. Now what's going to happen is that if you look back at our general form, we have u, but we're also going to have to take the derivative with respect to u. And we have v, okay? So if we have dv, we're going to have to take the integration of this. So if we take the derivative of u with respect to x, the derivative of the natural log is 1 over x dx. V equals the integral of the derivative of v. So we take the derivative of this, which is x to the fourth dx, and that becomes, if you remember, if you have x to the n, the integral of x to the n is x to the n plus 1 over n plus 1. So this becomes x to the fifth over 5. Okay? So now what happens is we're going to substitute what we know into our form of the integration. So I'm going to rewrite it here. And we have the integration of the natural log of x times x to the fourth dx. Okay? If you remember, what we did here is we rewrote the equation to look like that, equals u. U equals the ln of x, it's the natural log of x, times v. We know what v is, that's x to the fifth over 5. That's from here. Minus the indefinite integral of v, okay? So that's x to the fifth over 5 times du. And du, if you look here, right, we took the derivative of u with respect to x. That's 1 over x times dx. Okay? if we simplify, I'm just going to say ditto because this comes through. This becomes minus the integral, okay? You have an x here and x to the fifth. So this goes into this one time. So this simplifies to x to the fourth over 5 dx. I'm just going to scroll the screen a little bit so I have more canvas to work on. This then becomes minus, I'm going to take out a 1/5 here, right? Because x over 5, x to the fourth divided by 5 is the same as saying 1/5, and I can pull out constants of either an integration or a differential. X to the fourth dx. So really all I have to solve now is just this. And this becomes minus 1 divided by 5 times the integration of x to the fourth is going to be x to the fifth over 5. Okay? Since it's an indefinite integral, we're going to be putting our plus c. That's our constant. So the total solution is, I'm going to rewrite my original problem here, the integration of the natural log of x times x to the fourth dx equals the ln, right? Because this is just flowing all the way through. That's what these ditto marks were. The natural log of x times x to the fifth over 5 minus, okay, I have x to the fifth. I have two 5s in my denominator. I have a 5 in my denominator here and a 5 in my denominator here. I multiply that. That's 25 plus c. So that is my entire solution to the problem. So that is the answer. So this is a prime example. If we go back and look at our original problem of integration by parts, this is the form that we use. And if you go through it, it shows how we broke up the function into both the polynomial and the transcendental function, what we assigned u and what we assigned dv. We took the derivative of u and we took the integration of v, and then we substituted it back into our original form until we got the answer. So this is a prime example of how to use integration by parts. And if you have any questions, please go to my website, MathTutorMan.com, www.MathTutorMan.com, and you can send me an email or a question, and I'll answer you. And again, my name is Adam Racklin, up here. I hope you found this educational and instructional. I would appreciate your feedback. Take care, everybody. Bye.